All right, function operations and composition functions today. So this first part is asking me to find f plus g of 0. That means f of 0 plus g of 0. So you plug 0 into the f function, 0 into the g function, and you add your answers. When it wants f minus g of 4, again I want f of 4 minus g of 4. Plug 4 into the f, 4 into the g, subtract them. F times g of negative 2. Now, I want you guys to understand these are not the composite functions at this point. And here's what I'm referring to. Let me write that down. Okay, f open circle g of x, that's a composite function. That's plugging x into g and the g function into f. That's not what it's asking. See, problem C is asking me to multiply my two functions. So I need f of negative 2 times g of negative 2. I plug those in, and my answer would be negative 70. And again, you guys can pause these notes, and you can write stuff out, write your little notes, whatever you need to do on your PowerPoints. All right, this one wants f of 3 divided by g of 3. So plug in 3 into f, plug in the 3 into g. I'm assuming you can plug into the functions. If you can't, you need to see me. Now notice every single one of these had a number that I was plugging in. Every single one of these was a number for an answer. Note now there's not numbers anymore. These are x's. So the first one's asking me what's f of x plus g of x. I literally just need to add like terms. So that'd be x squared plus 1x plus 5. These are the only two here that were like terms. When you have f of x minus g of x, please remember for the minus that you want to remember to take minus 4x and then minus 5. So negative 3x minus 4x, that's the negative 7x, minus, that positive 5 was minus 5. Now this would be the equation of a parabola, so my domain again would be all real numbers, negative infinity to infinity. The next problem is asking me to multiply them, so I have a binomial times a binomial. Most of you will do boxes in here, so you can FOIL or box, that's up to you. So once you do that, then you want to combine like terms, and that's your final answer. And it wants the domain, so the domains again are all real numbers. I can plug in any number I want to for x as long as it's a real number. Negatives, positives, decimals, fractions, anything. All right, this one says f of x divided by g of x. So these are like the simplest ones, but they're not the simplest for the domain. Remember the domain you can never divide by 0. So when I look at that denominator, x can never be negative 5/4. So to write that domain, remember x can be any number in the world, real number, but not negative 5/4. So I have to do that with these open parentheses in this union symbol. So it goes from negative infinity to negative 5/4 because that would give me 0 on the bottom, and then pick it back up to infinity. So use the graph below to evaluate. So f plus g of 1, that means f of 1 plus g of 1. And that means you go to where x equals 1. Now the f function is blue and my g function is red. If you are colorblind and cannot see the difference in the blue and the red, we'll have to figure out a solution for you. So come see me because I do need to definitely figure out a solution. All right, so this is the f function for the parabola. The g function was the v. F of 1, that means go to the f equation. When x is 1, the f equation is 3. My g equation is 1. So I just need to add 3 plus 1, and the answer is 4. So again, I'm plugging in a number. I should get a number for an answer. All right, f minus g. So there, of 0. So f of 0 minus g of 0. That means when x is 0, what is f? So when x is 0, the f equation is blue. That's 4. Minus the red equation, 0. So 4 minus 0 is 4. All right, multiplication. F of negative 1 times g of negative 1. So when x is negative 1, the f equation's in blue. 1, 2, 3, so that'd be 3. The red equation is 1, so 3 times 1 is 3. When I have division, I need f of negative 2 divided by g of negative 2. So when x is negative 2, the f equation's in blue, which is 0. The g equation's in red, which is 2, so 0 divided by 2 would be 0. Now do understand, if this had been reversed, g of negative 2 divided by f of negative 2, that would have been undefined because we can never divide by 0. All right, sometimes they give the table format. Same thing. This means f of 1 plus g of 1. So here's where x is 1, f of 1, g of 1, so 1 plus 6 is 7. F of 0 minus g of 0. So when x is 0, f of 0 is negative 1, g of 0 is 4, negative 1 minus 4, negative 5. F of g of negative 1. So it's going to be multiplying. So f of negative 1 times g of negative 1. So when x is negative 1, f of negative 1 is negative 3, g is 2, multiply them, negative 6. And then division, I need f of negative 2. Negative 2 for x, the f equation's negative 5. The g equation's 0. Negative 5 divided by 0, I can't do. That would be undefined. All right, this is the brand new concept to everybody in both classes, whether you came from honors or regular. The difference quotient is a pretty difficult concept for students. This will be on your open response test, so it's very important. It's also on the final exam, so please make sure you come back and practice this one. All right, so the difference quotient, you do not have to memorize this. We give you the difference quotient rule. Now this tells me to plug in x plus h for every single x. So that's the first step I want to do. I just want to plug in x plus h for each x. So I'm calling that 3 times the junk squared minus 2 times that junk of x plus h plus 4. Then I want to minus the function itself. That's minus f of x. That means all of that over h. So here we go. So again, plugging in x plus h for each of these x's. Notice that 4 is still there. Then minus this entire function right there. Now, y'all, what's going to happen here is every one of these should zero out. If it doesn't, you've done something wrong. Now, don't just make it zero out because you can have another mistake too. All right, so the first thing you'll do is need to FOIL or box out x plus h squared. That's a binomial squared. Some of you have gotten the shortcut down, x squared. Multiply the 2xh, double 2xh. Last one squared is h squared. I distributed the negative 2x, negative 2h, kept my plus 4, distributed the minus 3, minus that negative, positive, minus that positive, negative 4. All right, now we distribute this 3. Now y'all see this 3x squared? Remember I said everything here should cancel. It should go 0 out. That and that gives me 0. 2x minus 2x. Negative 4 plus 4. Then what's left over, you should be able to divide an h into everything left over. And then these h's divide. And your answer is this. Again, this is going to take some practice. Okay, so when you get to this one in the homework, definitely hit similar exercise several times. Keep up in a Google Doc which one this is, because you're definitely going to want to go back and practice this one over. You can hit similar exercise after you've completed your homework and it won't change your grade. Alrighty, so now we're going to move on to composite functions. So the composite function here, this is a number, so I should get a number for an answer. This means plug 2 into g, and then that answer into f. Plugging 2 into g, 2 divided by 2 would be 1. Now I need to plug 1 into f, so it'd be the square root of 5. The next one, I want to plug 5 into f, so square root of 9, which is 3, and then plug 3 into g. So again, 5 into f gave me 3. Plug 3 into g, g is here, 2 divided by 3. And again, guys, these are numbers. I get numbers for answers. If there's a letter, then I get expressions for answers. So this time I need to find f composite of g, f of g of x. So y'all, this one has a letter, so I'm going to get letters in my answers. Now remember, this means I'm plugging g into the f equation. See, this is the junk right here, 2x plus 5, I'm plugging in for that x. So 2x plus 5 minus 1, that's 2x plus 4, and keep the square root with it. Now, it also asks for the domain. So remember, what's under the radical bar has to be greater than or equal to 0. So x is greater than or equal to negative 2 there. All right, then we have you turn it around. We have you do g of f of x. So now I'm going to plug f into g. I'm going to plug this one into here for that x. See, this f is going into g. So 2 times all the f stuff, and then plus 5. All right, so there's my equation. All right, domain, take what's inside the radical bar, greater than or equal to 0. So x would be greater than or equal to 1, including the 1 to infinity. All right, plugging in f of g of x and finding the domain again. So this first one's asking me to plug g into f. I want to plug this junk g in place of that x there for the f. So it's going to be 5 over 2 over x plus 4. So again, we've got to get that first step down. So that first step said plug g into f. So this 2 over x went in place of that. So 5 over the 2 over x plus 4. Now, y'all, I can't leave this fraction within fraction. So we multiply top and bottom by x. So the numerator is 5x. The denominator, when you distribute that x with this, the x reduces, and then 4 times x. Now, domain. Back here in the original, x cannot be 0. Right here, x cannot be negative 1/2. So I have not negative 1/2. I have it not at 0. That's the complicated domain. So again, right here, x can never be 0. Right here, x can never be negative 1/2. So for a lot of you, that will be easier to do that with a number line. So let me take a second here and do my number line. Negative 1/2, 0. Okay, so from the number line, see, x can never be negative 1/2, x cannot be 0. So this interval is negative infinity to negative 1/2, open parentheses, union, negative 1/2 to 0, union 0 to infinity. Okay, this is a little different than the true-false test, so don't be thinking these alternate this time. We're already just telling you x cannot be 0, can't divide by 0. Here, x cannot be negative 1/2 for the same reason. All right, I'm going to pick up the next example on the next video. This is already at 11 minutes.